In this lesson, we will be looking at explaining the domain and range of different rational functions. So here's a graph of the first rational function. And just so you know, I drew the asymptotes in, the dotted red lines, the spots where the graph is undefined. But on accelerated math or in your homework or on your calculator, they may not be drawn in, just so you know. So you're going to kind of have to think about that and see where it looks like they're undefined. But I drew my asymptotes in, or my dotted red lines in, of course, right here at 0, and right here where x is -3. um, all right, so let's first of all look at domain. Again, domain is what your x values can be. I am going to think about dragging this green line and thinking about where the green line would intersect with the blue rational function line. And it will always intersect here, and as if I move that green line across, it's intersecting, 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 intersecting. Right here, when I hit the asymptote, there is no blue line that can exist right there at that rational function. So the domain can't exist there when x is -3, okay? And then as I move, oops, I don't want that on there. As I move that green line across the graph, the green line, if I can find it and grab it, there we go. The green line will now hit blue, 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 and it will continue to hit blue all the way over here, even though the line doesn't extend that far. So basically, the domain will be everything except x equals -3. It cannot happen at x equals -3. So I would do this. Set of all x such that x is not, that's what I would do, -3. Okay, every number but that. The other way you could do that, just so you know, is you could do the set of all x such that x is less than -3 or x is greater than -3, but not equal to -3. So you could do it that way too if you wanted, but I think it's easier to just do it can't be -3. Okay? If we were to do it in set notation, or interval notation, I'm sorry, then we would go from -infinity up to -3, but not including -3, so you need the parentheses instead of the bracket, and then union -3 all the way up to +infinity. Okay, so that's our domain. Our range will be very similar if we go up this way. My blue line would intersect the rational function, of course, would continue to go down and down and down and get closer and closer and closer to that asymptote as it went down. But the blue and the green would eventually intersect here, 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 here. They're not going to intersect right here where there's an asymptote at 0 when y equals 0, but they will intersect as they continue to move this green line up this way. So they will intersect every place where y is any number but 0. And then, of course, in interval notation, we would go from -infinity to 0, and then from 0 up to +infinity, but we can't include 0, of course. Okay, here's another one. I'm going to just give you the answers to these. You can try this one on your own. And again, the asymptotes might not be drawn in here, but this is what it'll look like. So if you want to fast forward through this one, it's very similar to the last one. You can completely do that. Excuse me. But there's the x values. Okay, and then the y values can be everything but 1. Okay. All right. This one has got more than one asymptote in it. And so when we move across and we look at our domains and I move this green line across, it will not intersect right here where there's an asymptote at -4. And it also will not intersect here where there's an asymptote at 3. So I would do this. X can be everything, but it can't be -4 and it can't be 3. So I would do something like this. X cannot be -4 and x cannot be 3. And you might even want to do it like this. This is probably better. But it can be anything but that. Okay? Domain-wise, we're going to go from -infinity until we hit -4. And then we're going to go in between -4 and 3. and then we'll go from 3 to positive infinity. Okay, but it can't be exactly negative 4 and it can't be exactly 3. Your range, if you go up and you look at your y values, I will always intersect a blue line here, 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 here. This is the only spot I won't intersect a blue line, and then of course all the way up. Okay, so I will intersect that blue line from negative infinity up to 0, but not 0, and then from 0 up to positive infinity. And in set notation, it would look like this. Your y value cannot be 0. Okay, this one again is very, very similar, so I don't think you need to worry about that, and I think we're going to stop right there.